Okay, great. Welcome back. Part two. So as I was going through part one, if you were, watching carefully or, kind of remembering some of your atomic structure from the past, you may have been wondering, hey, what's the deal with the neutrons? I thought that atomic nuclei had to have some neutrons in there. So that's what we got to talk about next, okay? I wanted to start part one by just focusing on protons and atomic number, and I wanted to emphasize that the identity of an element is determined by the number of protons in the nucleus. Okay, so that's a very important concept. So hopefully you've got, maybe you got that written down in your notes somewhere. Okay, here we go. So what about neutrons? Okay, so let's the very first atom that we made was hydrogen, right? And I'm just kind of giving you a little extra information here. Hydrogen is this is one type of hydrogen atom. You'll notice there's a proton, one single proton, that's what makes it hydrogen, and there are no neutrons in here, right? That is the most common form of hydrogen in the universe by far. And the relative abundance, that's just a fancy way of saying, this is the percentage of all hydrogen atoms that have this configuration in the nucleus. That is, there's no neutrons. Okay? Now, I want to introduce now a notation that we're going to be using throughout this unit. And that is, this is called the, I believe we call it the nuclear symbol. Okay, so in your notes, I want you to write down, nuclear symbol, and then copy down this this notation. So basically, this is the anatomy of a nuclear symbol. You've got the abbreviation for the element, and hydrogen is H, and then you've got these two numbers over to the left. There's a superscript and a subscript, and here's what each of them means. The subscript is the atomic number of the particular type of atom that we're talking about, and that, as you know, we said this in part one, the atomic number is the number of protons in the nucleus. Okay, the superscript is what we call the mass number. Okay, so make sure you've got that in your notes. And the mass number, by definition, is this. It gives you the total of the number of protons and the number of neutrons in the nucleus. All right, so obviously for this form of hydrogen, there's only one proton, there are no neutrons, so the mass number is 1. Okay, so it's 1 over 1 for this particular type of hydrogen. Now, let's consider another type of hydrogen. Okay, so if you place a single neutron in here along with the proton, we have not changed the identity of the element, right? Because we've not changed the number of protons. This is another form, a different form of hydrogen, and it has a special name. We call it deuterium. Deuterium, and you can see from the relative abundance that it's fairly rare. It's less than 1%, less than 1/10 of 1% of all the hydrogen in the universe is this form. Okay, and so now, can you tell me? See if you can write the nuclear symbol for this form of hydrogen. Go ahead, give it a shot. All right, so hopefully you came up with this, right? The atomic number is the subscript, and because we still have one proton, we haven't changed that, that's still 1. But now we have to change the superscript to a 2, because we have one proton, one neutron, 1 plus 1 equals 2. So the mass number is 2. And by the way, this type of hydrogen, deuterium, is what you find in something called heavy water. So if you do some reading about, say, nuclear power, or the nuclear industry, or maybe the Manhattan Project back in the 40s when they developed the atomic bomb, you'll see this term, heavy water, and all that is, it's just water molecules that contain deuterium instead of just the usual normal hydrogen. All right, and finally, we don't have to stop with one. We can actually put two neutrons in the nucleus of a hydrogen atom, and that forms a third type of hydrogen called tritium. Okay, and tritium, if deuterium is rare, tritium is like almost negligible. There's very, very little of it naturally occurring, but when you do find it, as I say here, it is radioactive. Okay, so what would the nuclear symbol be for tritium? Okay, give it a shot. Okay, hopefully you had 3 over 1. If you got 3 over 1, you are absolutely correct. All right, so how do we refer, what's the term for these 3 different types of hydrogen, right? We call them isotopes, and you probably remember that, right, from either physical science or middle school. So we've got hydrogen, where there are no neutrons at all, and that's by far the most common type of hydrogen. Then you have hydrogen where there's 1 proton and 1 neutron. That's called deuterium. And then you have a third isotope, which is very, very rare, with 2 neutrons, called tritium. These 3 types of hydrogen atoms are all called isotopes. So that's an important term that you need to know. All right, so let's take a little break here and just make sure that we understand everything. So here's a definition. Here's one definition that you could that you will read for isotopes. Okay, so they're atoms of the same element, but they differ in the number of neutrons. Okay, so let's check here. All right, so let's say you have been given 2 atoms, atom A and atom B, and you've been asked to determine whether the 2 atoms are isotopes of the same element. But you're only allowed to ask 2 questions. If you could ask 2 questions, what would they be? In other words, what information would you need to know in order to determine whether these 2 atoms are in fact isotopes of the same element? So think about that for a second. Okay, and here we go. Oh, by the way, you may not ask this question. Okay, so we will talk about this tomorrow. I'll check your answer on that. But for now, let's just summarize this. So back on part 2, when we made helium, I want you to know that the complete nucleus of a helium atom has not only the 2 protons, but most helium atoms have 2 neutrons as well. Okay, and so what would the symbol be for that? Okay, so the atomic number in the bottom would be 2, because you got 2 protons. And then what's the mass number for this? That's right, 2 protons plus 2 neutrons would be a 4. So that's 4 over 2. Okay. What about the carbon that we made in part 1 of the video? Okay, I'll tell you there are 6 protons, 6 neutrons. So what is the nuclear symbol? Okay, hopefully you came up with 12 over 6, right? 6 protons, that's the atomic number. 6 plus 6, that's 12. All right. And then finally, this is the last slide. Now, I want you to go through this, and I want you to make a little table in your notes with these 6 headings. So go ahead and push pause, and I want you to create that table before we go on. Okay, so I'm assuming you've got that done. Now, what I'm doing here is each of these 2 rows corresponds to a particular isotope of a particular element. And in each of these 2 rows, I've given you just enough information that will allow you to complete the rest of the row. All right? So I'll go through the first one with you, and then I want you to do the second one by yourself. All right. So you know that for this isotope, you've got 7 neutrons, and the mass number is 13. Okay? So using the mass number, we can figure out how many protons we have, right? Because we know how many neutrons we have. All right, so follow me on this. So in your notes, you should have this definition. Mass number is simply the total of the protons and the neutrons. So if you're trying to figure out how many protons something has, you just do a little algebra, right? So you just subtract the number of neutrons on both sides, and you get this. So number of protons equals mass number minus the number of neutrons. And so here we're going to have 13, which is the mass number, minus 7 is 6. So we know that we have 6 protons. Now, if there's 6 protons, what element is that? Now, hopefully you have your book so you can consult the periodic table, or just remember from earlier in the presentation we saw an atom that had 6 protons, and that was carbon, right? Okay, now if we have 6 protons, how many electrons do we need to have a neutral atom of carbon? That's right, you got to have an equal number of electrons and protons in order to have a neutral atom. And then finally, use the information here to derive the nuclear symbol for this. Okay, and then push pause if you need to, if you want a little bit extra time to figure it out. All right, so here we go. Down here, so obviously the nuclear symbol, you got to have the abbreviation for the element, carbon, which is just C. And then we remember that the superscript is the mass number, right? So I take that number and I bring it down here into the subscript. And then the subscript is the atomic number, which is equal to the number of protons, which is also equal to the number of electrons. So bring that down. So this, my friends, is the nuclear symbol for this isotope of carbon. And specifically, it's called carbon-13. All right, so now you try the second row. So hit the pause button, and I want you to take a couple minutes and see if you can do this. Okay, so here come the answers. Because it has 92 protons, you can go to your periodic table, find the element that has an atomic number of 92, and you see that corresponds to uranium, which is a U. Okay, since it has 92 protons, it's got to have 92 electrons, and the mass number is simply 92 plus 143, and therefore the nuclear symbol would look like that. Okay. All right, so thanks. I hope that felt comfortable, and we'll talk about this tomorrow. All right, have a good night.